Thank you for the introduction. And I also would like to thank Alexandra for inviting me to this meeting, and Phyllis and Sylvia to respond to my endless questions. The things are pretty different here and there. So hopefully I'm learning so much from your presentations, and I hope you can get some good information from mine. This was working perfectly when we practiced, but of course. Okay, just a quick reminder that why we're here and why we're having this meeting, because it's known by pretty much everyone in our field that mosquitoes are the deadliest animals in the world. We have outbreaks more often, affecting the human health, public health, and the economy. So even though budgets are getting tighter and tighter for everything, we still lucky to have support to do mosquito research, especially operational ones. Next one. And although there's so many mosquito species, we are concerned about a handful of them for nuisance and disease transmission. And the reason that we're here today is the one that particularly contain and inhabiting Aedes mosquitoes, which are responsible from the transmission of dengue, chikungunya, and Zika. What do we do when what do we do when we have disease outbreaks? Any arboviral disease outbreak? The first thing that we think about is, if you're in the control side of the things, to do ULV adulticiding to knock down those gravid, potentially infected adult females. Which also, surprised me when I asked Norbert. He said, no, we're not allowed to do any adulticiding, and I can't even think about not having adulticiding in Miami when we have locally transmitted dengue cases and like in 2016, a Zika outbreak. But the conventional wisdom says Aedes mosquitoes, the container inhabiting Aedes mosquitoes, are active during the day. So nighttime ULV adulticiding would not be effective control against them. My wisdom would be for this is to just to test, even if it's a surveillance method or a control method, it's always good to test for your situation, because everything works differently in different cases. When we looked at the Aedes albopictus populations in New Jersey when I was stationed there, we found out surprising results that Aedes albopictus was active, most active during the noon time, but the activity among afternoon, morning, evening, and nighttime weren't really significantly different from each other. So what we started doing is to do the ULV adulticiding when we have high numbers and keep monitoring the populations. And we determined that we achieved 72 to 98% of decrease in the populations following the adulticiding. But the problem is very transient. After 5-8 days, you need to repeat it again. But if you have the disease outbreak, that's one thing that you have to do. Next one. So why is it so challenging? Again, this is something that we know. You name it, you can find the larvae and the pupae of this two species all over the place. And I heard Dr. Alton mentioning it's a backyard mosquito. That's basically what it is, and making it really challenging, because in the county, we have inspectors. When we get phone calls, they go out, and the first thing they do is whoever called you, go into their backyards and front yards and inspect. But even the individuals who call for the service, they don't want you to do anything in their backyards. Even though you explain them what the situation is, they want you to just do adulticiding. So, but the challenge is they're everywhere in their exotic habitat, in not mostly natural habitats, but the artificial containers, they thrive the most. Okay, so this is a great example what we need to, I've seen all these nice and neat pictures from you guys and the airport pictures, and I felt like, oh boy, they're lucky. You know, this is what we need to deal with, and sometimes it's even worse. And it just makes the point that, you know, source reduction, even though seems to be the best approach to reduce the populations of Aedes aegypti and albopictus, even with 26 inspectors, in Miami-Dade with all these supervisors, once June, when we hit June, there's no enough people to do this work. And then when we received the Asian Tiger Mosquito Project, again, when I was stationed in New Jersey, we tried all the conventional methods and failed nicely, and see what we can do. And this was already out there by Valent, that doing the area-wide applications, and we started doing it too. And it really cuts the amount of time that you spend to treat the areas. But you know, everybody who does this work, you need to you know that you need to check what's going on after you do the treatments. So we looked at different containers. And again, this is a very open, the best case scenario. We laid out different containers, and we called the containers, such as these ones, open containers, and the Coke bottles, and those elongated, corrugated extension gutters, the cryptic ones. And we drove the buffalo turbine with the BTI and see the penetration. However, we didn't get good results with the cryptic habitats, and just to confirm this results, Wynwood and Miami, Florida, we are still to this date, after 2016, every week, 2 night shift crew members go there and do truck mounted larviciding. And each week we get numbers that we do not want to see. So that means, okay, we're accomplishing something, but we're definitely missing so many things that, you know, I think a month ago, I got like 560 Aedes aegypti from a trap while we were treating this site every week. So the challenge is out there, but what are we going to do about it? Next one. So auto dissemination concept, I think it's the brilliant idea that since we cannot afford to do all this work, let the mosquitoes to do the work for us and see if it would work. So the idea came from Ito in 1994. They started working with the species Aedes aegypti and tried to contaminate mosquitoes and the containers with the contaminated, using the contaminated mosquitoes. Chisholm and Epperson tried the same idea with a small cage experiment, and they did also get promising results. When we get to 2009, Divine revived the idea and started testing in a bigger but still small scale with the Aedes aegypti populations in Peru. Next. Auto-dissemination formulations that are available, as we know, pyriproxyfen is the juvenile hormone. You can see the effects on larvae, pupa, and emergence of adults, and also found that the females that are exposed to pyriproxyfen has lower egg numbers. And the potency is really high. Just a minute amount of pyriproxyfen is enough to achieve mortality. Sumitomo granules were available when Rutgers started working with this project, and we came up again. Dr. Wang is the mind behind all this. We had oil EC formulations, powder WP, and gel. And as you can see, all the active percent of the active ingredients really high. And we also know that there's an IntoCare device that also tested in a few counties in Florida, which also use pyriproxyfen and a fungus for attractiveness. Next one. Dissemination strategy heavily depend on pull and push. What we want to do is to pull the mosquitoes to a device where they can get contaminated with the juvenile hormone, pyriproxyfen, and then push them out before they lay eggs to the device. And just to depend on their behavior, skip over position that, they go from one container to another and another and keep contaminating. There's also ADAM technique. Dr. Dobson's group also worked with done, and they contaminated males and released them. And they also got a good result in a small field experiments. Heterodissemination is a whole other topic that our group tested. And we already have 2 publications. If you just go Google Scholar and type my last name, those publications are start popping. Instead here, we're using mosquitoes, but if you use chironomids, or in another case that we use frogs to disseminate the pyriproxyfen, that's the concept that, we developed to control mosquitoes. Next, please. Okay, you might need to help me with the animation. Just quickly, just to visualize the concept that you need to attract the mosquitoes to for the contamination, and then the mosquito does the work for you, and you expect to have emergence inhibition in the end of the process. This is Divine's experiment, just quickly, that he deployed OV traps, and then traps that are contaminated with pyriproxyfen, and looked at the mortality rate in the bioassays from the larvae and pupae, and he achieved observed 42 to 98% control. For Rutgers University, they started working with this prototype. The objectives were long-lasting oviposition attractant technology, cover entire season, because just remember, we want to cut off the amount of work we're putting out, auto refill, overflow protection. So with the rain, the natural events, you want the trap to fill up, but then you don't want to overflow so the mosquitoes still freely come in. Tested out multiple formulations to support and decide the best one. Definitely no maintenance traps, and user-friendly, even for residents, which will be a good citizen science project that, just to get the citizens to do it themselves in their backyards. Next, please. So this is how it started in 2011, and it has been a long time. When I looked at this, if you have kids, you're probably familiar with it. I might tell contact Niantic, this might be a nice Pokemon. It looks like a weird device. If I weren't telling you that this is their first device to track and pull, push mosquitoes. In 2012, you can see that the device is getting a little bit more sophisticated with the top layer where the mosquito comes in and gets all the pyroproxyfen and comes out next. And then the reason that also you're seeing all these things that, you know, usually when you test these devices in a small room situation, what do you expect? You have great results. So, but as you take them in the field, then you start seeing what the problems are. So with the 2013, that was their device, and then you can see here's the pyroproxyfen, and in 2014, in 2014, where I come into the picture, we start putting these devices in the field, and here's where their formulation is. Again, we found problems on 2014. The powder formulation started caking and then leakage, and they, instead of putting on the side of the trap, they decided to put it over the trap for the protection with the cover. Next, please. And then Mother Nature, we took the traps out and the spiders started to play with the traps, and they blocked the entrance where the mosquitoes were supposed to go in. And also you still have Aedes albopictus in Northeast in September, but the leaves started to drop. Again, a blockage problem. In 2015, of course, we reported to Rutgers, to developers, and next one. And then they started looking at solutions by looking at the device design, looking at the attractants, formulations, and quality control. Next one. Okay, this was the last one we tested out in 2016, and we got really good results. And you can see this big opening now to avoid the spider webs and the leaves. And here comes the results. Again, each time we took these devices or traps, whatever you want to call them, in the field, we did the small room experiments. Consisted of just putting a trap, one of those auto dissemination station in the middle of the room with 10 Sentinel Cups, and release mosquitoes. And as you can see, once the water samples are collected and the third instar albopictus is released into those cups, 100% mortality. Next. And then in Mercer County, New Jersey, we took the traps out and we used 120-acre urban area, consisted of 8 blocks, 4 control, 4 treatment. And we kept them in the field 3 months, which is basically Aedes albopictus, how long the Aedes albopictus season in the state. Next, please. Okay, so we had 1 BGS trap to look at the adult numbers. Push, push, push. And then we did barrier treatments around these study sites because immigration is a big problem when you do a study like this, because constantly adult mosquitoes keep coming into your trap field sites. And then we deployed 20 OV traps, total of 20 Sentinel Cups, and then 10 stations per acre for the treatment site. In order to determine and evaluate the efficacy, we looked at the adult populations, egg populations, larval populations, and also conducted larval bioassays. Okay, this is our adult population, the the counts on the X axis and the Y axis, and the red are showing the treatments, and the blue lines are showing the control sites. Very discouraging. You know, when we saw this results, Dr. Gogler actually didn't want to see them, because a lot of work goes into this. We did think about the immigration. We did think about so many things. And as you can see, the trends of adult populations in the treatment and the control are pretty much the same. There wasn't any significant difference. Next. But when you look at the egg populations, this is totally different picture, very encouraging. The site with the Aedes, auto-dissemination stations have significantly lower eggs than the control sites, which is supporting the idea of definitely, you know, the immigration of adult mosquitoes are a problem to see the big picture. And then the other pictures, even though you need to do your power analysis prior to, you know, your experiment, also there are operational limitations, how many BGS traps you can deploy, who's going to ID them. So even though later years we increased the BGS traps, now I'm looking at what Lee County is doing for their SIT program in Captiva Island. If you Google it, it's like a hair thread, like a small island, and they deployed and are deploying 200 traps for 2 years to establish their baseline data. And then they're still doing it, and 3 nights a week. Tremendous amount of effort to do the surveillance to determine what the difference in the population. So if you think about only 2 traps in these sites, it's definitely also not enough. But the OE traps and the Sentinel Cups are more in number, so it is giving you more data to see the little differences. And the next larval, when we do the bioassays, we again see very encouraging results, auto-dissemination, and this is the probably scientist's dream come true, because you have a control site that is lower than your treatment site, and it keeps going up throughout your experiment. And the site that you treated, even though it starts with a higher population, it keeps going and it plateaus out. These are the Sentinel Cups again, and we took the water samples every 2 weeks. Again, this was another hurdle to go. We didn't know if we should do 1 week or 2 weeks. You know, when you submit the papers, some reviewers asking, why are you not doing it 1 week? But the point is, contamination takes time. When you do this experiment for a 1 week, there's not enough time to capture that period that the water sources are contaminated. Again, very encouraging pupil mortality that, you know, from 25% to almost 90% mortality in the cups when we collected water samples. Next. And we didn't stop there. We even looked at the natural containers, the things that actually just there, and we started getting samples from them, brought it to the lab. Again, we inoculated the 13-star larvae. Again, the contamination is present. The containers were getting contaminated by the mosquitoes carrying pyroproxyfen. In conclusion, this is a very promising idea, but my dilemma is always that if you look at the publications, it's always been tested out by itself, and we keep saying integrated pest management, but I also know how difficult and expensive these trials are, because the number of treatment sites and everything goes up. Definitely worth testing this in an integrated pest management scenario. there's no doubt that we were successfully pulling the mosquitoes in the devices and pushing them out. That wasn't a problem. And without sticking to the slide, I think this is the time that, during my presidential messages, which I just wrote the last one a couple days ago, that, with Aedes aegypti and Aedes albopictus, we just have to think outside the box. It's because the good old ways that we know and use successfully against Culex and Aedes vaccines is definitely not working for these two species, and always challenging us every day to do and think about something else. Thank you so much.
Thank you very much, Isik.